Design of interchange systems. Welcome back to Blueprint to Reality, where we uncover the design logic behind the world's most essential infrastructure. Today, we're diving into the complex and fascinating world of interchange systems, those intricate webs of ramps and bridges that guide traffic through highways, expressways, and major urban corridors. They may look like a tangle of roads from above, but every curve, every ramp, and every loop has a purpose. Let's explore what makes interchange systems such a critical part of modern transportation. What are interchange systems? An interchange system is a grade separated junction where roads meet, typically allowing vehicles to transfer from one highway or arterial route to another without stopping. Unlike intersections that rely on traffic signals, interchanges are designed to keep traffic flowing continuously, avoiding conflict points and reducing delays. Think of them as three-dimensional road puzzles, elevated and layered in such a way that vehicles can shift direction, merge, exit, or cross without colliding. This is key in areas with high-speed, high-volume traffic, where efficiency and safety must coexist. Why interchanges matter? Without interchange systems, major roads would constantly be interrupted by intersections, causing massive congestion and delays. But the design goes beyond just movement. It's about capacity, safety, economy, and land use. Efficient interchanges reduce traffic bottlenecks, eliminate stop-and-go situations, and drastically cut down on accidents caused by crossing conflicts. In fact, many modern cities depend on well-designed interchanges to optimize regional mobility and support economic growth. Types of interchanges. There are several types of interchange systems, each tailored to specific traffic demands, available land, and budget constraints. Cloverleaf interchange. One of the oldest designs, this consists of 4 loop ramps allowing for all directional turns. It's compact but can lead to weaving issues as cars enter and exit closely. Diamond interchange, used where a freeway meets a minor road. It's simple and cost-effective, with ramps forming a diamond shape, often signalized at the crossroad. Trumpet interchange, typically used when one major highway ends at another. It includes a loop to reverse direction and streamline merging. Stack interchange, a complex, multi-level solution where roads cross at different heights. It eliminates all conflicts but requires extensive space and investment. Directional interchange allows for direct high-speed turns between major highways using flyovers instead of loops or merges. Ideal for intercity expressways. Each design balances safety, space, and traffic flow differently. Engineers choose based on projected vehicle volumes, speeds, and available land. Engineering considerations. Designing an interchange is not just about drawing ramps on a map. It involves deep analysis of traffic patterns, forecasting growth, and understanding driver behavior. Engineers ask key questions. How many vehicles will pass through per hour? What is the percentage of turning traffic? Are there heavy vehicles like trucks or buses? How much land is available, and what are its constraints? Once the traffic data is analyzed, the vertical and horizontal alignments are calculated. Grades, slopes, radii of curvature, and merge lengths are all optimized to ensure smooth and safe driving conditions at design speeds, often exceeding 80 kilometers per hour. Land use and cost constraints. Interchanges are expensive. A single interchange can cost millions depending on complexity, land value, and terrain. Urban environments often pose major challenges due to limited space and existing developments. In such cases, engineers must think vertically, adding multi-level stacks, split-level roads, or even underground ramps. These vertical designs reduce land usage, but increase construction costs and complexity. On the other hand, rural or suburban areas allow for horizontal expansion, making room for cloverleafs or trumpet designs that are easier and cheaper to build. Safety features in design. Interchange systems are designed with driver safety at their core. This includes adequate sight distances on curves and merges, proper signage and lane markings for guidance, crash barriers and guardrails on elevated sections, drainage systems to prevent water accumulation on slopes and ramps, a lighting to improve visibility during night and adverse weather. Special attention is given to weaving zones, where entering and exiting traffic crosses paths. These zones are either minimized or eliminated through collector-distributor lanes and advanced signage. Innovations in modern interchanges. Modern engineering has introduced smart and space-saving interchange solutions, including diverging diamond interchanges, DDIs, where traffic briefly switches sides to allow unimpeded left turns. Single-point urban interchanges, SPUIs, where all left turns are controlled by a single traffic light at the center. Turbo roundabouts and hybrid interchanges combining traditional ramps with roundabouts for better land use. Additionally, technology is being integrated with interchanges. Sensors monitor real-time traffic, and adaptive signals manage flow during peak hours. Some cities are exploring automated vehicle-friendly interchange designs, optimizing for self-driving cars that require smoother transitions. Real-world examples. Famous interchanges like the Judge Harry Prejerson interchange in Los Angeles or the High Five interchange in Dallas showcase the height of complexity, multi-level, high capacity, and engineered to handle hundreds of thousands of vehicles per day. In contrast, rural trumpet interchanges on national highways are simple but effective, connecting small towns with the national road network and supporting regional access and trade. Whether massive or minimal, every interchange is a solution to a specific traffic problem designed to balance geometry, safety, cost, and performance. As cities grow and traffic demands evolve, interchange design will continue to push boundaries, making roads faster, safer, and smarter. Thanks for watching Blueprint to Reality. If you enjoyed this journey through the loops and ramps of highway design, don't forget to subscribe for more deep dives into the engineering that shapes our world.